Hi and Assalamualaikum. My name is Adam Daniel and today I'll be presenting for the numerical project Optimum dosage of coagulants, and this is an open-ended learning level 3. This is our group members. Firstly is me, Adam Daniel bin Abdul Hadi. I'll be presenting for the introduction and objective. The second one is Muhammad Arshad Sheikh Moran. He will be presenting for the procedure. The third one is Leong Gyok Bin. She will in charge for the results and analysis. The fourth one is Khairun Sofia binti Harun. She will present for the discussions, and Lu Zhengyan will present for importance of JAR and the conclusion. So for this lab, the JAR test is a simulation of conditions in water treatment plant by simulating what will happen to the raw water in the treatment after the chemicals have been added in the process. So basically, it is a scales down of the water treatment system. It is very important so that we can try alternative treatment doses and strategies without alter the performance of full-scale treatment and follows contemporary trial and error. So the objective of this JAR test is to determine the minimum coagulant dosage required to achieve certain water quality. So what is turbidity? Turbidity is the optical measurement that indicates the presence of suspended particles. It can be measured by shining light through a sample and quantifying the suspended particle concentration, where the higher the turbidity, the higher amount of particles in the solution. Turbidity in water may caused by presence of suspended matter such as clay, silt, finely divided organics.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Ashar and today I'm going to discuss about the apparatus used in this experiment. The apparatus required for this experiment are first and foremost jar test apparatus. Then we require pH meter, turbidity meter, 6 measuring pipettes, sample tubes, and last but not least standard turbidity suspension. Now then, let us look into the methodology for this experiment. Firstly, we require 6 beakers, each of 500 ml sample, and then they are placed under paddle. By using a measuring pipette, coagulant is added to these beakers in an increasing amount of 10 ml, 20 ml, 30, 40 and 50 ml respectively. Each beaker is then stirred rapidly for 1 minute, followed by a very slow and uniform stirring for 15 minutes. And then each beaker is then left idle for 10 minutes in order for the flocks in the beaker to settle. Then we pipette out 10 ml of clear sample from each beaker, and then we calibrate turbidity meter by using standard turbidity suspension and set it to 0. Sample tubes are then taken and washed using distilled water, and they are dried using a tissue paper. Then we take the previously prepared samples and then transfer them into sample tubes. Make sure to prevent entry of any additional air bubbles from the environment. Last but not least, the values of turbidity is read using the turbidity meter, and they are recorded in the datasheet.
Hi, I'm Leong. I will now explain about result and analysis. This is the data provided for our group. The LM concentration is 100 mg per liter, and the volume of the jar is 100 ml. We are required to determine the coagulant dose. Taking data jar number 2 as calculation example, we will use the formula M1V1 equals to M2V2. Therefore, we will obtain 19.62 mg per liter for M2. From the graph, the optimum dosage is 21 mg per liter, and the turbidity at optimum dosage is 2.7 NTU. That's all from me. Thank you.
My name is Khairun Sofia binti Harun, and I will continue the presentation to the next part, which is discussion. So what is coagulation? Coagulation is the action or process of a liquid that changes into solid or semi-solid state. It is one of the common methods used by water treatment plants to provide safe, clean drinking water to public water customers. Examples of coagulants are ferric sulfate, aluminum sulfate, and ferric chloride. There are some factors that might affect the accuracy of the results. Firstly, error may occur if the sample did not shake well before taking the water from the sample, which may cause the residue suspended at the bottom. Besides, parallax error might occur during the measure of the volume of the sample needed. Therefore, there are some methods that can reduce the errors. Firstly, Pour the sample carefully and not to introduce air bubbles into the sample tube. Lastly, the coagulant should be added simultaneously in increasing amount into each of the beakers to prevent unbalanced stir in each beaker. That's all from me.
Therefore, the conclusion is from the experiment result, the optimum dosage for the water sample is 21 mg per liter and the minimum turbidity produced is 2.7 FTU, stands for formazine turbidity unit. The next is the importance of jar test. This is the sample picture of a jar test, and the purpose is we need to estimate the minimum coagulant dose required so that the water has achieved certain quality goals. The second objective is to identify the right quantity of treatment chemicals, such as the lowest dose of the chemical that provide the satisfactory settling amount that is used to treat the water efficiently. That's all from our presentation for Group 5. Thank you very much.